In this lecture, I will talk about velocity, acceleration with a practical example. So I'm going to take an example that this is an individual A. He starts from his home and he wanted to reach to his school. And on the way, he stops at McDonald's. So this is the school where he wants to reach to. And then he picks up his food stuff and then goes to the McDonald's. Oh, then goes to his school. Now, starting from his home and to reach to McDonald's, it takes him 10 seconds. I'm just taking our SI units. Obviously, it's going to take more time, but just to make the calculations really easy and simple, so I'm taking the units of time in seconds and units of length in measurement in meters. Then this person has covered, let's say, 200 meters in 10 seconds, and he reached to the McDonald's. And this is an east direction. Then he stops at McDonald's for again for 5 seconds, takes his breakfast or lunch, and then reaches to his school. To reach to his school, it takes him 20 seconds more, and he has to cover 400 meter. And then he does his work, he stays in school. Let's say, again, I'm taking the units in seconds for the time. He stays in the school for 15 seconds and then starts going back to the home and doesn't stop anywhere and directly reaches to his home. And this total distance travel will be obviously 400 and plus 200, that will be 600. And this time around he takes let's say 25 seconds to reach to the home. I wanted to first of all find out the velocity, then the acceleration, and I wanted to draw the velocity and acceleration graph, and then I'll add the displacement graph too. Displacement in that too. Displacement. So first of all, if I were to find out the net displacement covered by that student will be will be zero because he ends up being exactly at the same point from where he started after covering his journey. But if I'm trying to find out the net displacement between his home and school, then it will be equal to 200 plus 400. That will be equal to 400 plus 2, 600 meters. That will be the displacement covered by the person from his home to reach up to his school. But if he comes back home, then the net displacement will become zero. Now I wanted to draw the displacement time graph first of all. So how can I draw the displacement time graph? So displacement will be on the y-axis and time will be on the x-axis. And this direction I'll consider as east. And obviously, if this is east, down here this will be west. Now, a person started from his home. This is the origin point. He covered a displacement of 200 meter in 10 seconds. So it will be a slant line starting from this point, and he covered 200 meter in 10 seconds. So let's say he's here 200 meter. Then he stopped at McDonald's for next 5 seconds. So this is 10 seconds. For next 5 seconds, let's say that point is here. He is at McDonald's. So this will be a horizontal line. Now, then again, he started. He started going towards his school. So if he start going towards his school and he's consuming certain amount of time, it will again be a slant line like this. So this will be a straight line. It's looking a little curvy, but it should be a straight like this. Okay. And if this point was down here, I'll mark this point as 15, this point as 15, and then this point down here will be 15 plus 20. That comes across as 15 plus 20 will be 35. 35 seconds. So after 35 seconds, he will be in his school. Now, in school, he stays for 15 seconds. So remain next 15 seconds. I have to extend this graph. So for next 15 seconds, he stays in the school, doesn't go anywhere. So this will be a horizontal line. So horizontal line means no displacement. And obviously I can see it on the graph down here also. The displacement is not changing. And up here also the displacement is not changing. And then he moves back. He covers 600 meters in well, I should represent meters down here too. So 600 meters in 25 seconds. So shall I draw it in the west direction? Pause the video and think about it. So welcome back. Now I'm not going to draw it in the west direction because he's right now here. So from this point he's moving in the west direction, so it will be like this. So that's how I'm going to draw it. So 35 plus 15 is 50 second, 50 plus 25 is something 75. So this will be 75 seconds. So that's how I will draw the displacement time graph for his complete journey. Now, I wanted to find the velocity, and I wanted to find the velocity for each section. Before I start finding the velocity, I wanted to tell you that velocity formula, which is equal to V final minus, not V final, D final, D final minus D initial divided by time. This formula gives us net average velocity. Average velocity. It's really important to understand because later on we will have some other types of velocity: initial velocity, instantaneous velocity, and then we will have final velocity too. So the velocity from this formula is the average one. Now, average velocity, as the name suggests, it will be a horizontal line. You will always get by this formula something like this, a horizontal line on velocity time graph. Okay, I'll talk about this in detail later on, but first of all, let's find out the velocity. So I'm going to mark these sections. So this is section 1, this is section 2, this is section 3, this is section 4, this is section 5. Now, how much is the displacement covered by the person in the section A or in the section 1? The displacement covered is 200 meters. So 200 meter in 10 seconds. So it will be V average is equal to D final minus D initial divided by time. Now D final with respect to this section I will take. He is in the section 1. Here he is at 200 meters. He started from 0. So it will be 200 minus 0 divided by time. Time taken was 10 seconds. So that will be equal to 20 meters per second. That is the average speed. V average. This is for section 1. Same way I'll find it for section 2. For section 2 I can clearly see he is not moving. If he is not moving, his displacement is not changing, which I can say down here it is 200 also, and he's at 200. So V average in that case value will be, in case 2 will be 200 minus 200, that is equal and divided by time, which is 5 seconds. This is 0 meters per second. Another way of looking at this is you can always see if the displacement time graph is a horizontal graph, then there is no velocity, and you can guess it for section 4 now also. So down here there will be no velocity because the displacement is not changing in this section. So now let's continue with this question and let's look into the part 3, so our section 3rd, this section. So he covered how much displacement? He covered 400 meter in next 20 seconds. So 400 meter. So that will be 400 minus, well, this is what I want to tell you. This displacement I'm considering as 400 meter. So he will, down here, he will be at what point if I have to draw it on the graph? And this will be 600 meters because this point is 600 starting from this 0. Okay, so this will be 600, I will mark it as this point is 600 and this is 200. So 600 minus 200, that will be equal to 400 divided by time, and the time he has taken is 20 seconds. 20 seconds, and this is V average, which is equal to 400 divided by 20, and this will be 20 meters per second. That will be for the section 3. And initially for section 1 it was the same, and section 3 is also 20 meters per second. And for the final section, we'll find the velocity, that will be equal to v final d final minus d initial divided by time, and this is v average. And d final is he ends up being at home, so 0 is final displacement point is 0 minus, and 600 will be the point down here. This is 6, he's in 600 east direction, so I'll keep this number as positive. This negative sign belongs to the formula, that's why I placed a negative in this equation, divided by time, and the time taken by that person in this case is 25 seconds. It is 25, I can show you down here again. So this is 25 seconds. Okay, and now negative 600 divided by 25, I'll do some calculations on my calculator. 600 divided by 25, which is 24, negative 24. Now negative 24 means his velocity is negative 24 meters per second, or 24 meters per second in west direction. So we figured out all the velocities, and now we wanted to draw them uh, on the velocity time graph. So how I'm going to draw it on the velocity time graph? So this is velocity, again this is east, this one will be west. So for the section 1, for the first section where we started, it was it was this is section 1, 20 meters per second. So section 1 is 20 meters per second, it will be drawn like this. And section 2, what is his velocity? For section 2 we've done it here, 0 meters per second. This was his velocity, so I will mark it on the graph down here. So this will be down here. This is for section 2. So this is section 1, this is section 2. Then for section 3, again it was 20 meters per second and it was positive, so I'll draw it down here. So 20 meters per second, I can show you, it will be, this was down here. So that was for section 3. And then for section 4, I have to extend my graph. So this for section 4, it is down here, this red line. Let me sharpen up my pencil. So this will be the darker line, and then after this he ends up moving in the opposite direction at 24 meters per second in the west direction. So I will draw it in the west direction, means down in the bottom half, so somewhere here. Notice all of them are horizontal lines. Now horizontal line, why? Because this is an average speed. So during the first event it was an average velocity. This is average velocity, this is average velocity, this is average velocity. They all are average. You can join them with a thick line, but that thick line has no relevance. This brown line which I am drawing has no relevance because there is no time has been elapsed in this. What was the time here? If the time, let's say time here was 10 seconds, this was 10 seconds, and down here the time is also 10 seconds. So this brown line has no relevance to it. Okay, so hopefully you were able to understand how you're going to draw the velocity time graph and how you're going to find the velocity average if you are given the displacement and the time. Now from this I will continue dwelling on this one. I will try and draw the acceleration time graph and find out the acceleration. So if I wanted to find the acceleration, I will look into the velocity time graph. For the first one, it was 20. Let me note it down and zoom it in. This was 20. This was 20 meters per second. Meters per second east, because they're positive, and this one was 24 meters per second in the west direction. So acceleration value will be equal to v final minus v initial divided by time. Again, this is also average, during that particular journey. So for section 1 we're trying to find, so v final, this is final, down here it is 20, up here it is 20. So acceleration for section 1 is, 0. So this will be, let me show you the work too. So this will be 20 minus 20 divided by time. This was over a period of 10 seconds. So this will be 0 meters per second. Now you can guess it. For this section there is no velocity, so obviously acceleration is 0. This is again a horizontal velocity, so acceleration will come out to be 0. For this one it will be 0. For this one again it will be 0. For all these sections for all these horizontal lines, acceleration came out to be 0. Now if you see carefully, we've drawn some kind of a trend. So one of the trend is, if I show you, I kind of lost the track of the diagram. Yeah, so if I see it carefully, when we had a horizontal line on the dt graph, it led to the no no line on the velocity time graph. It was like this means no line, it is on the axis. Okay, whenever there was a horizontal line for section 4 and for section 2, it was a horizontal line for section 2, and this is 4. For these two there was no graph. Same process happened when there was a horizontal line for acceleration. Wherever there is a horizontal line, there is no graph. So what conclusion we can draw? If the displacement time graph looks like this, then the velocity, even if you're not given the numbers, there won't be any velocity. I can clearly see there is no displacement, so no graph on the velocity time graph. And this is velocity time graph. And then if the displacement time graph is a slant line, then you will get the velocity time graph, and that will be a horizontal line. And then there won't be any acceleration time graph, because this is a horizontal line which leads to no graph. Now, if it is a curved graph like this, there are multiple curved graphs. We will talk about them in detail also, but I just wanted to sum it up right now. And if it is a curved graph, then you will find there will be a slant graph on the velocity, and then that will lead to a horizontal graph on the acceleration time graph. So this is the process we will follow. Now it depends where you're going to draw this line. Obviously this is a positive slope, so I've drawn it on the top end. If the graph is a little different, it will be drawn maybe in the bottom half or somewhere else. That we will talk about in the next lecture. So hopefully you got something out of this lecture. So, and if you like the lecture, feel free to subscribe. Think about subscribing it. Otherwise, I'll see you in another class.